All right, let's dive right in. For the next few minutes, this is your top-down strategic briefing on the future of the smart cockpit. We're not just talking about surface-level trends here. We are breaking down the four fundamental forces that are completely rewriting the rules for HMI development between now and 2026. This is the analysis your engineering team needs to see.
And honestly, this quote from BMW CEO says it all. It marks the end of an era. The whole screen size race, just slapping a bigger tablet in the car and calling it innovation, that's over. The new North Star, the only thing that really matters now, is the actual, tangible user experience.
So that raises the big question, right? Is this whole philosophy that has driven car interiors for a decade, bigger screens, fewer buttons, is it actually done? I mean, the entire industry has been marching in this direction, but that march just slammed headfirst into a wall, and this wall wasn't put up by designers.
Okay, so to really understand what's happening, we've broken it down into four key forces. We're thinking MISI here, mutually exclusive but collectively exhaustive. First up, we're seeing a comeback of physical controls. Second, there's a revolution happening in the silicon that powers everything. Third, a whole new battle is heating up for in-car AI. And fourth, the global market itself is literally splitting into two. We'll wrap all this up with some concrete engineering recommendations.
So let's start with that wall I mentioned, the most immediate and disruptive force of them all, the physical renaissance. And let's be clear, this isn't some retro design trend. It's a full-on regulatory reset that's forcing every car maker to make a major course correction.
And you can see the conflict laid out right here. For years, the goal was this smartphone on wheels concept. But now, the Euro NCAP 2026 mandate is here, and believe me, it is a huge deal. Regulators have now officially said that hunting through touchscreen menus to turn on your wipers is an unacceptable eyes-off-road risk. And starting in 2026, taking that risk will cost you a 5-star safety rating.
So what does this actually mean for your designs? It means these 5 functions you see here, your turn signals, hazards, wipers, the horn, and your SOS button, they must have their own dedicated physical controls. This isn't a suggestion. It's a non-negotiable rule that basically sinks any design that buries these things 3 layers deep in a menu.
But the answer isn't to just throw a bunch of clunky old plastic buttons back on the dash. No. The real strategic play here is what we're calling phygital interaction. So think of a beautiful premium rotary dial that gives you that satisfying click as it moves through a digital menu. The engineering challenge here is massive, though. These controls need their own direct, low-latency signal path that completely bypasses the main operating system. Why? Because your horn needs to work instantly, even if the entire infotainment system decides to crash.
All right, so let's move from the controls you can touch to the silicon that does the thinking. The second major force is the one-chip revolution. For decades, the hardware for the cockpit and the hardware for automated driving were in their own separate boxes. Well, those walls are coming down. Everything is converging onto a single, incredibly powerful chip.
And right now, the whole market is being shaped by 2 giants with 2 very different approaches. On one hand, you've got NVIDIA's Drive Thor. It's an absolute beast with 2,000 TOPS. That's 2,000 trillion operations per second. It's a true server-grade computer designed to handle both L3/L4 autonomy and the cockpit. Then you have Qualcomm's Snapdragon Cockpit Elite, which is laser-focused on creating the absolute best in-cabin experience for L2+ systems, really prioritizing graphics and generative AI.
Now, you're probably thinking, how on earth can you run your critical speedometer and some buggy third-party music app on the same chip? Well, the answer starts in the hardware with something called a functional safety island, or FSI. The best way to picture it is as a tiny independent bulletproof computer that lives inside the main chip. It has its own power, its own clock. Its only job is to run the vitals. So if the main part of the chip running all the fun stuff crashes and burns, the FSI is totally fine, and it keeps your instrument cluster running no matter what.
So if the FSI is the hardware bunker, the hypervisor is the software that enforces the lockdown. Think of a software layer like QNX as a digital bouncer. It creates these virtual walls, an impenetrable firewall between the safety-critical stuff, like your speedometer, and the open consumer stuff, like your apps. This guarantees what we call freedom from interference. It means your Spotify app can never crash your turn signal indicator. Period.
All this incredible computing power leads us directly to our third major force, the battle for AI. But this isn't about who has the smartest AI in the cloud. The new war is being fought right there on the edge, inside the car.
And it's a battle against time, measured in milliseconds.
For years, all we talked about with AI was accuracy. But now, with conversational AI in the cockpit, the game is totally changed. The new all-important KPI is something called time to first token, or TTFT. Put simply, how fast does the AI feel? You know, when you ask it a question, how long is that super awkward silence before it starts talking back? If it's more than a second or two, the whole illusion of having a natural conversation just falls apart.
And this chart shows you exactly why this is an edge battle. If you try to run a large language model on the main CPU, you're looking at a nearly 10-second delay before you get an answer. That's, well, it's unusable. But if you take that exact same task and run it on a dedicated neural processing unit, an NPU, that response time plummets to under 1 second. That is a 10 times leap in performance, and it's the only reason we can even have real-time on-device AI conversations.
Of course, having a fast AI that just makes stuff up is even worse. So to stop AI hallucinations, the best systems use a technique called retrieval augmented generation, or RAG. It's actually a pretty brilliant and simple process. When you ask the car a question, the AI's first move isn't to guess. It first searches a local trusted database, like the digital owner's manual or live sensor data. Only after it finds the facts does it generate an answer, based only on that data. It keeps the AI grounded in reality.
Okay, let's zoom out for our final strategic pillar, because all of this amazing technology doesn't exist in a bubble. The fourth force that you absolutely have to grapple with is that the global car market has fractured. We are now operating in a dual-speed world, with two completely different ecosystems running by two different sets of rules. And here's why that matters from a strategic point of view. The Asia-Pacific region now accounts for more than half of the entire global HMI market. That's not just a big piece of the pie, it is the new center of gravity. The sheer scale, and more importantly, the speed of that market is now setting the pace for innovation everywhere else.
And when you put these two markets side by side, the differences are just stark. You have China operating on a blistering 24-month development cycle, where consumers actually expect cutting-edge, sometimes even beta features at launch. Compare that to Europe and the US, which are on a much more methodical 36 to 48-month cycle, with an ironclad focus on safety and privacy. One world is built around Baidu, Alibaba, and Tencent. The other is dominated by Google and Apple. You just can't have a one-size-fits-all global strategy anymore.
So, we've covered the four key forces: the comeback of physical controls, the one-chip revolution, the AI edge battle, and this new dual-speed world. So what does this all mean for you, right? How do you actually translate this strategy into execution? Let's boil it all down into some direct, actionable recommendations.
First, you have to adopt a mixed criticality architecture. Using a hypervisor and an FSI isn't nice to have anymore. It's table stakes. Second, build an edge-first AI strategy. Your target for time to first token has to be under 1.5 seconds, using NPUs and grounded with RAG. Third, front-load your thermal simulations. These new chips get incredibly hot, and you can't treat heat management as an afterthought. And finally, you have to automate your HMI testing. For things like latency and driver distraction, it's the only way you can possibly keep up.
And that brings us to the central strategic question that every engineering leader should be asking themselves right now. As we try to navigate this new dual-speed world, we are facing a fundamental choice. Will it be the blistering speed and rapid innovation of one market, or the rigorous safety and architectural stability of the other, that ultimately defines the winning formula for the cockpit of the future?